Hey everybody, welcome back into another fun and exciting geometry class. Today we're going to be talking about polygons. And that word polygon actually comes from the Greek, and it means many. That's what poly means. And gon is the idea of angles, so many angles. We typically, when we think of polygons, we think of the sides, but the Greeks kind of talked about the angles of the shape. And really, that's where the core of the shape is, in its angles. So we're going to go ahead and talk about those today, and then we're going to talk a little bit about what's called regular polygons as kind of an extension to the first part. But a polygon is a figure that's closed in, so it can't have any openings in it. The whole thing has to be closed, so it's got to come together at the end. And there has to be sides, has to be straight lines, and there has to be vertices or angles where the lines are intersecting, where the lines are touching. I told you this when I talked about the triangles, but the side that the shape is sitting on, here's an example right here. The side AB is the side that it appears the shape is sitting on. And so that side, AB in this case, would be called the base. Now, if we turn the shape, we could make the shape stand on BC. And so BC would be the base. So it doesn't really matter, it's just what it's visually looking like is the base. You can call that the base. Anything could be the base. Any of the sides could be the base. Same thing is true that we had in triangles. We can have what's called interior angles, okay, the angles on the inside. So that would be like A, B, C, D, and E. Those are the interior angles. But just like, again, with the triangles, when we have the side kind of extend out a little bit, then B can also become an exterior angle. So this yellow one here would be the exterior angle. Notice again, just like with triangles, that exterior angle forms a straight angle or 180 degrees or a line. And so B or ABC, the interior, or we could call this G out here, and so CBG. Notice these two together, what do they form? Well, they form a straight line, okay, 180 degrees when you add them together. All right, so that's kind of the basic ideas of the polygon, very, very similar to the basic ideas of a triangle. These two sides, for example, AB and BC, notice that these two lines, they touch each other, okay, at a point called the vertex. So they touch right there. This line touches this line. So these two lines would be what we call consecutive lines or adjacent lines. Consecutive or adjacent. Consecutive means in order or in a row. Like 1, 2, 3 is consecutive numbers. So they're in order, they're in a line. And so these angles here, or these lines here, are in a row, they're in an order. They come after each other. And so then the next one, the next consecutive one would be CD, and then DE, and then EA. So that's a consecutive pattern all the way around the shape, also called adjacent. Each one of those would be adjacent to the one before it and adjacent to the one after it. They're always adjacent to 2. So AB would be adjacent to BC, and it would also be adjacent to AE. Let's see, a couple more things here. Convex. A convex polygon is a polygon that has all angles less than 180. I guess this is what we would be used to seeing for a shape. This would look like a normal shape to us, a typical shape. And so what we have is we have a shape that every single angle is less than 180 degrees. So there's nothing, no reflex angles in there. And what it creates is a shape it's called convex. It's all contained inside. So AB to BC, these angles are all less than 180. Now, the other type of shape would be a concave shape, concave. One angle is greater, at least one angle, is greater than 180. At least one angle is greater than 180, or a reflex. So if you look at this, that angle there, A, that's less than 180. This angle's less than 180. This angle's less than 180. This angle's less than 180. But look at this one. You see how that's a reflex angle? Okay. Now you're like, no, look, in here it's less than 180. That's an exterior angle. We're talking about the interior angles here. So make sure that you're not looking at exterior. We're looking at all the interior angles. So if you look at that interior angle of angle C is a reflex, or it's greater than 180. So that makes that shape concave. It's a concave shape. Okay. All right, I think that's about everything from page number 23. If you'll turn over to page number 24, we'll talk about regular polygons. Regular polygons. This is interesting. Regular polygons. A regular polygon is both equiangular and equilateral. It's both equiangular and equilateral. So let's take a look at this. Here's what this means. Okay, we have a shape, and if all of these angles, let's call all of these angles right here, and we'll say that all of these angles are, I don't know, what does that look like? Maybe, actually, well, I'm just going to throw out a number, and we don't know if it's going to work out, or we don't know if it's going to be perfect at this point. There's a way to figure out what those angles should be, but I'm just going to kind of put a number out there. Let's say they're all 110 degrees. Okay? So all of those angles, those are all 110 degrees. Every single one of them. 110, 110. Okay, you get the idea. All of them are 110. Now, also what has to be true is it has to be equilateral. All the sides have to be the same. So this has to be 7, 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 this has to be 7. So they both must be equilateral and equiangular, both to be considered what's called regular. A regular polygon is equilateral and equiangular. And there in the chapter, you'll see in the lesson, you'll see where it shows you how to build one of these, how to take one and actually construct it. And I'm going to go ahead and show you that now. Okay, let me show you this here. What I've done is I took my shape that I want to draw, which is 5 sides, and I divided it into 360, and that gave me 72 degrees. Each side, each angle right here is going to be at 72 degrees. Now, I'm using a computer, and my measurements aren't perfect, but what I did was I tried to put the protractor on here, get it as close to 72 as I could. So then I went to this one, and then I went to this one, and then I went to this one, and I just worked my way around, and I put every angle at 72 degrees. Okay, so all those angles are written in there at 72 degrees, more or less. Some of them aren't perfect, but they're close. So now I have my, it ends up forming like a star shape, if you will, depending on how many legs you have, how many sides you have. It's going to look a little bit different. So there we go. I've got that. Now the next thing that I want to do is I want to actually try to draw the shape. And the way that I'm going to do that is I'm going to choose how long I want my sides. Now remember, all the sides will be an equal length. So, and you can have them at whatever you want, but I'm going to come over here and I'm going to put my my compass here, and I'm going to put it at wherever I want, okay, however long I want the sides to be. For this example, I'm going to put everything at 3 inches, or 3 centimeters, I think this is. So I'll lock this in at 3. So now this is at 3. So when I come up here, I'm going to put a mark here. I think I'm going to put a mark there. I'm going to try to put a mark there. There we go. There's the mark. Okay. And then I'm going to move the pencil around, and I'm going to put one at the next spot. So I'll put one there. It's a little bit hard to move this guy around. He likes to jump around a little bit. So I'll put one there, and then I'm going to attempt to get one over here somewhere. There we go. And then I've got one more. So let's see how this one works. So let's try to get him over there. All right, there we go. All right, so now I'm going to take my compass off, and you can see, here's what I've done. I've put all of these marks at 3 centimeters away from the vertex. And so now what I would do is I would come over here with my straight edge, and this is a little challenging, maybe more than a little challenging. It's a lot challenging. So what I'll do is I'll show you here on the first one, and then I'm just going to skip the video ahead to when I have them all done. Alright, so there's my first one. I've got it there. And so now I'm just going to connect those. Okay? And what I'm going to do is I'm going to go all the way around the circle, and I'm going to connect those. And there we go. There is our shape. We've got a pentagon, 5-sided, and so each one of these sides is going to be 5. I think we did 5. No, I think we did 3. How about that? So 3, 3, 3, 3, and 3. Okay, so all 5 of those sides are 3 centimeters each, and it is what's called a regular shape because they all have the same angle and they all have the same length each side. Okay, one more thing. Here is the center of a regular polygon. And the way that you find the center of a regular polygon, cut this angle in half right here. If you were to take this angle and cut it in half, and take this angle and cut it in half, take this angle and cut it in half, take this angle and cut it in half, and then take this angle and cut it in half. This point that is formed in the middle, this point right here in the middle, that point is called the center of the regular polygon. Okay, and it makes sense because it is in the center of the regular polygon. But the way that you would do that is you would cut those angles in half. Bisect always means to cut in half. So you cut the angles in half, and where all those lines meet, that is the center of the regular polygon. Okay? Let me show you just one more thing. I showed you how to do that with 5 sides, but I want to show you how to do it on something that has maybe 8 sides. So what we would do is we would take 360 degrees and we'd divide it by 8. And so, you know, you can come over here and we'll grab our calculator real quick. We can do 360 divided by 8 equals. So these are all going to be 45-degree angles if we're doing an 8-sided figure. Now, on the 5-sided figure, we got 72. And so the more sides, the smaller the angle is going to be. The less sides, the more the angle is going to be. Okay, so that's the way that you do that, and you can put any number here, any number of sides. And I think the book calls this n sides. N. N is for the number of sides. So that's your little formula right there. You put it on n for n sides. So if you have 8 sides, n would equal 8. If you have 5 sides, n would equal 5, just depending on what you have for the different sides. Okay? All right, that's all I have for you today. I hope you have a good day. Bye-bye.